Hello guys, so welcome to the tutorial about to create your own turret. So today I'm gonna talk about how you can actually implement the turret without using any stuff like pawn or pawn sensing, because sometimes you don't need it. For example, in my own game, I have a system where you just create your buildings, so you just build, and from the programming perspective, it all comes down from one class, which is not pawn. And now I needed to create a turret, so it should work like, without any pawn sensing, because it's derived from the class, which is basically it's just an actor. And to actually implement the pawn, I would need to go through a lot of settings, a lot of setup, a lot of programming to actually create it. So here we will go with the approach about creating only from actor and without any pawn. So that's why I'm creating this tutorial. We will go in depth and fix any errors like the wrong calculation of the rotations, because sometimes the engine can go false with the, or go wrong with the rotation when it comes down to the 1 degree to 359 degree and stuff like that. So first I want to talk about is that we actually can just model ourselves the turret. Sometimes I really like to do that, well, most of the times, to be exact, because you can just block out very easily with the Unreal and just create the basic stuff here. And you can just program it, test it, and if it's fine, then okay, you can change the models later. So let's start. The first thing I'm gonna do is go to the modeling tools, and I'll just create a box. Alright, so nice. Well, and after that, let's pretend it should be the turret, not the base, but the body. The stuff that will hold the turret gun. So I'm just gonna go to poly edit and start to moving it a bit. So maybe I'm gonna just extrude it. So here we are, just switching to the modeling. And we can just go with extrusion just to create something that can resemble a turret body. So we can even go like that. Maybe we can extrude a bit here. Just so it looks like a bit like something is actually holding it. Okay. That should be enough. Now I will move the pivot point, so it will be located like here, and after that I will just mirror it. Yeah, not the best thing, so just to rotate it. Yeah. So something like that. Alright, so now we have like a simple, very basic turret body. And yeah, it's centered okay. So now I will create a gun. So again, let's create a box. And the polygon edit, let's do it something like here. Move it a bit closer to the body. So yeah. And again, let's the poly edit. Let's move it a bit. Something like that, yeah. And let's again extrude it. And we can actually make it not so wide. Alright. So something like that. Yeah. Oh, maybe I just extrude it a bit more to actually do something like that. So yeah, that's the basic gun. One more thing I forgot to worry about to do is to create like, you know, a stick on which the body is standing. But okay, we'll do it a bit later. Right now, I just wanted to change the pivot points to actually be centered. Yeah, that's okay. All right, great. So with the turret body, I will just edit it a bit. And I will also extrude it, not so much. So what I want here is just to create like a leg for it. Yep, something like that. Now I just need to convert this to the actual static mesh. So I can actually use it later. And also the same for the gun. Right, that's it. So now we can actually start to create the turret. So we're gonna go with the blueprint class, and it will be just an actor, nothing else. So we'll call it something like basic turret. And right now I want to add this something like maybe a cylinder, which will be a turret base. Well, something close to that. And after that, for the default scene root, I will also add a turret body. And to the turret body, I will add a turret gun. So the hierarchy will remain, because we want the gun to rotate with the body. So for the body, we'll pick up what we just created. And also for the gun. Oh, so as you can see, I did a mistake. The leg is not right here, but okay, let's let's just let it stay like that. It will be a very strange leg for the turret, but it will work. So okay, right now, let's see how the rotation will go. Yep, not bad. I think that will be enough. We can even go like a bit, scaling this up. Yeah, we'll be fine. So the first thing we need to think about is how fast our turret should update itself to actually catch any target. Because you know the turret like need to scan the surroundings to really understand what she should aim at. So the first thing that we'll create is the new variable, and we will call it a target class. This could be any actor, and we will target at the class reference, so we can just pick up any target we really want. For the testing, we will be using our like default character, so when we're playing, yeah, I just need to set a right game mode for that. Right, looks like here. Let me check. Looks like I have the third person game mode, yeah. So yeah. That is just a testing point that I've been using, so it's a bit different than the third person game mode default, but nothing too much really. So yeah, it can just throw some errors. The character, because I was like, you know, using it, changing it. So, all right, I'll just delete some stuff. So it will show no errors. Yeah, great. All right. So we have a target class. Now we need to understand how fast turret should, you know, catch the actors. How frequently should do it. I'm not a fan of using the event seek for that, because we can actually set up a timer for that. So that turret would not check for the actors like every frame. We will set up our own timer and we can change the time if we need to. So let's create a new timer. You can use by event, by function name. That's not a big difference, to be honest. And for the time, we will promote this to a variable and we'll call it update target time. I think 0.1 will be enough for that. So at like 10 times per second, the turret will update its target. We'll set a little looping and we'll create a custom event, which we'll call something like update target. Nice. So after that, we can really start creating our own function for the actual target search. So first thing we want to check is that our target class is not equal something empty, because maybe we forgot to, like, you know, set it, and could be a problem. So after that, we need to create an actual reference which will hold our current target. So this will be a new variable, which will be an actor, but it will be an object reference. So after we check that our target is not empty, we're gonna get a validated get of our current target. Because if we don't have it, we can actually search for it. If we have it, we can search for, you know, different things. So okay, let's suppose that we don't have it. Then we can call sphere overlap actors. That's the actual function that allows you to get rid of any, like, you know, collision boxes, collision spheres, and any of stuff like that. It will just get a sphere, and everything that overlaps with it, it will just return all the number of the sectors. So okay, sphere position will be like, you know, get actor location, so where our turret is located. And sphere radius is actually a turret radius. So we will promote it to something like turret range. How far turret can target stuff. So for the actor class filter, we are using target class. For the object types, we can just make array and put something like world dynamic, something like pawn, maybe a vehicle, and also something like destructible. That should be fine. You can also use actors to ignore if you want, but here we will not use it. Okay, so we've got the sphere and we're checking if we're overlapping everything. Let's check that array of out actors is not empty, because if it's empty, we will not do anything. After that, we can actually check something like if we have, like, you know, a special components, or maybe your actor could be, like, you know, destroyed. Because, for example, you have a bunch of AIs which have health, and when their health is 0, they die. But they're not just being evaporated from the existence, so they can actually be, like, you know, destroyed, but the body of them remains, so the actor could still be there. And turret will think with this function that it still exists. So if that's the case, you need additional checks to actually understand that this target is not suitable anymore. So just for the example, we'll create something like a component, actor component. We'll call it something like PP destructible. This is the component that will hold, like, the variables for the health. We can add it to any actor that can, like, have health. So something like the current health and max health. Both of them will be float. And we can create a simple function, something like, the change health. And we will just call the amount. And for the current health, we're going to add it. So we can actually add different numbers. So it can be negative, it can be positive numbers, so we can either heal or damage the target. So yeah, we can use something like, the apply damage or apply point damage, but let's don't use it right now. So after that, we can clump it. So the values will not go like from the 0 to the max health. And after that, we just set the max health to current health to this. All right, so by default, let's assume it will be 100 and 100. That's it. So next, for example, let's create something like BB target, like third target. So let's add something like a cylinder. Something like that. And let's add the component destructible. So we can actually like see the change of the health. And here, like for example, let's do the event point damage. We can actually change health. So the damage goes like positive, but will turn to negative, and we call change health. And for example, if we are getting here like our current health equals 0, then we can call something like is dead. So we set this bool to true. So we assume that this target is dead right now. So on the turret, we can actually like check all the targets that we have and find a suitable target, so that even if it still exists, we will check is it dead. And because we're using the component that we will attach to any actor, we can still basically like target any actors as long as they have the destruction component. So let's create a new function, and we'll call it something like find suitable target, which will receive an array of an actor object references. So it should be pretty easy. Just go with a cycle for it, and we're just checking, does it have the destructible component? So we're checking, is it valid? And moreover, is it not valid, but is the target is alive? So it's not dead. And if that's the case, we can actually like create local variables. We will call it like suitable actors. Should be an array. And we just added it. This array elements. So, okay, if we have this component and the target is not dead, then it should be suitable now. And after we completed the cycle, we can add the return node. which will return our suitable actors results. And we'll just go with this array. So that's it. That's a simple check. So in the search target, if it's not empty, we're going to find suitable target. And if this array is also not empty, we can, after that, try to find the nearest actor. Okay, then we'll go with find nearest actor. With okay, let's get actor location. So turret will pick up the closest actor to it. You can always implement different things for that, but for now, it should be fine. And if everything's okay, then we set the current target. All right, so that is if the current target is not valid. What if it's still valid? We need to check. Maybe it left the range. So let's check. We can just use node get distance too. And the other actor will be ourselves, and the current target will be the target. And if it's more than our turret range, it's gonna for this branch, we can actually erase the current target. So it will just go like that. So, and after that, we can get back to the sphere of other vectors. So we'll try to find another one right after we lose this one. But what if false? We need to check if this target is still alive. Because while we are attacking the target, it can be dead in some time. Yeah. So we'll like get component by class and destructible component. And let's check, is it dead? And if it's dead, we'll just erase the target again. And let's search for the other targets as well. So that's it. That's the basic search target function. Right now in the event graph, we can just apply this function to it. So something like that. Okay, so now the turret can actually find the target. And for example, we can just put it here. And for example, put a few targets. I'll delete this one, something like that. We also need to, like, you know, set update target time is okay, and turret range, for example, will be 3000. So we can actually check if it's gonna find us something. So let's just play it. And after that, I will just go here and check. Do we have something here? There, search target is updating. Where is it now? Let's check it. Yeah, it updates. So let's continue the execution. Find out. Yeah. All right. Here's the problem. We don't have a target class set up. Yeah. So I'll make it like, you know, the visible. And let's put it to the target. All right. So let's find it out. Yep. Go in here. And it says, okay, it's not valid. Right. Let's check it again. Now. Right. And it still says that, yeah, it's fine something. But really don't want to go to the next node. Yeah, for some reason. So let's debug it a bit. You know what? Let's just create a print string. Just check if it's picking up a target at all. Okay, it doesn't. So let's check why. It's really strange that it doesn't want to pick up a target. Oh, yeah. It's gonna be false. My bad. Also here. It is empty. Sorry, my bad. Should be okay now. Yeah. It got here to the current target, so the current target is set. Alright, nice. So the next thing we can actually do is to rotate the turret to our target. We're going to be using the event tag for that. And first thing we want to do is to promote a variable the delta seconds. We will use it to smoothly interpolate our turret. And we can implement a new function which we'll call rotate to target. This is going to be a hard one, but stay with me. So, first of all, we're checking, do we have a target at all? And if we're having it, we're going to use the math to actually find the rotation that we'll need to rotate. So we'll be using the set world rotation node for the turret body. Alright, I will split this because we will rotate it by the Z, only by the O, and nothing else will be touched. Alright, let's get the body again. We're going to be using the world rotation. And we also will need the world location here. Why we need a world location? To actually find our target. Find the rotation at this target. So for the current target, we'll also get the get actor location. And we will use a find look at rotation node. Nice. So now we actually have a Z that we need to rotate to. What about the other thing? So we'll also need the, our current yo is here and the target yo is here. But because of how Unreal Engine calculates the rotation, there could be a real issues when your turret might just go in circles to actually rotate for the more degrees than it actually should to. So first thing I want to do is just to redo the node from the C++, which is the find delta angle degrees, but in the blueprints. So it's a pretty easy one node. There is not a big math here, but for the sake of the tutorial, we're using the blueprints here. We'll create a new function. We'll call it find delta angle degrees. And here we'll just create a few floats. Something like maybe A1, A2, because we can reuse this function for many stuff. And what it actually will do, we're going to be checking if A2 minus A1, and if it's more than 180, we will just subtract 300 degrees from that. And that's the value that we will return as the delta. If it's false, we also will check again. if it's less than minus 180. And if this is happening, then we will add the 360 to it. And that will be our delta. And if nothing else, we'll just return this as a delta. So what we're actually trying to do here is to make, or like, you know, the delta to follow only this range. So we're actually checking for the rotation to find the shortest route available to rotate to. Because sometimes, for example, when a 1 degree rotate can come and the turret on the 359 degrees, this can just happen, so your turret will go all the way around rather than just move by a few degrees. So this function helps to prevent that. Alright, so after that, we're going to be using the find delta angle degree. And before we will do anything to that, we will normalize the yaw axis to get rid of any negative values, just in case. Alright. So now we will put the current target to A2 and the world rotation here from our party, the current to A1. And it's gonna be if it's valid. Okay, so we got the delta. What do we gain more? We don't need for the turret to, like, you know, instantly snap to the target. We want to actually move it, and to move it with some value, some speed. So I'll create a new variable and I will call it something like maximum turn speed. It's gonna be a float, and it will be decreased basically. So let's say something like 60. Alright, and now what we will do, we'll multiply our maximum turn speed by the delta seconds to actually understand how much our turret can go in a one frame, because delta seconds is the time that been from the last frame. And we'll understand how much we can rotate our turret with what step for each frame. So after that, we will clamp our delta here. So we're using clamp float, and we're gonna clamp it with the result for our multiplication, but -1 to a +1. So like that. And for the rest of the thing, we just want to add the world rotation yaw here to the actual result, like that, and set it as a new rotation. Right, nice, that's it. So that should move our turret right to its target. So let's check how it will work. If everything is okay, it should rotate to this target here. Alright, nothing happened. Really interesting what's happening. Oh, maybe, yeah, I think I forgot to, I forgot to put the function to the event tick. Yeah. So, as you can see, our turret rotated and did it. Not so fast, without any, like, you know, snapping. Let's check something like that. Yeah. Alright, nice. Let's turn to our target. I wonder if I can, like, you know, move it in the game. Yeah. So as you can see, the turret rotation works really well. And if enough, well, we'll try it, like, you know, yeah, it lost the target. But even if I try to move it really fast, or move it behind the turret, so to, you know, start to bug, maybe it will not. So it actually will rotate to the target always. Nice. So now we can go and rotate our gun. Because right now we have only rotation for the body, but we also have a gun, so we want the gun to point actually at the target itself. Alright, so we have a like look rotation here, so it will be also our target here. Yeah, shouldn't be a target here, but yeah, we will not be using it. We will be using the pitch for the gun. The gun should be a pitch. So right, we have a turret gun, and what we're going to be using is that we will use the relative rotation here, because we want to change the rotation relative to the body, not the world rotation. This will create a bit of the bugs that we don't really want to deal with. And here, because it will be not so, will not be such problems like with the body, you can just use interrupter. For the delta time, it should be around just delta seconds. For the interpolation speed, we can use something like, you know, our own variable, something like maximum gun turn speed, and we can go with the maybe like multiplying 0.03 and put in something like maybe 75, for example. So you can actually change these variables to anything you want to, then, like, you know, set the rotation speed of the gun itself. So what we want to do here, we can just use a interrupter to set the relative rotation of the gun. So I also split circuit pin, and here we will work with the pitch. And for the interrupter, I want to split this also and use only pitch. You know what? Actually, I will just split everything of that to something like that. Alright, nice. So what I want to do here is also to change the limits. So our gun can actually would not go like to the ground or backwards. So it have a pitch limit. I will say something like gun pitch min and gun pitch max. So for example, the gun pitch min would be something like maybe minus 50 degrees, and gun pitch max could be, for example, 80 degrees. And we will use this clump for the target. So we have like a target pitch here, so we'll use the clump float. And here will be our gun pitch min and gun pitch max. Alright, nice. Now all we need to do to actually understand how we need to rotate it is to find the relative rotation. Could be a bit hard, not real, because for some reason I found that it bugs out. I don't know why. So the easy way to do that, we will add it to our turret body as scene component. We will be using scene component to revert our rotation from the world rotation to the local rotation. Because why? Because we need a current target. We need to get actor location to actually understand where it's located. And we'll be using this scene component here. We'll be using the get world transform. and we will use find relative look at rotation. For some reason, if you just put a turret body for it or turret gun, it will bug. But with this setup, when you place like the sync component and you will make a math from it, it works okay. So let's split it, and we will use the pitch here to actually clump it. So this is our target yaw, so where our gun should look. For the current yaw, it will be just really easy. We're gonna get the relative rotation and the current pitch, not current yaw, current pitch, sorry. It will go like that. All right, so we have a relative rotation right now. Let's test it out. So I will put targets over here. Yeah, so our gun is now not looking right at the target just because the axis is flipped. And the way why it works like that is just because the it doesn't look at the actual x-axis here. As you can see, it looks the opposite way. We can also try to fix it with the pivot point here. Can rotate it by 100 degrees. Yeah, but it will not help. So that's the problem when you're creating the models. Keep in mind that, oh yeah, it's now fixed. Should be. Alright, let's pretend I just choose files with save and without this map. Yeah, so always remember what axis your model is facing when you are actually using it. And let's test it out right now. Alright, great. So our gun is facing right at the target. Nice. We can also lower the rotation rate so we can actually see how it's turning. So let's go maybe for something like really slow, like 5, just to test things out. Yeah. And as you can see, the gun was go up very slowly. Let's check again. Yep. Still moving very slowly. Nice. Alright, so now our turret can find the target. It can aim at them correctly. Now we need to let it fire. And the way I like to do this is to actually check, is it facing the target already? And if it is, we can actually fire the target. So what we're gonna do here now, so we will create a new function that we'll call check if can fire. So here we'll use a bunch of different transforms with the thing of that we want to understand how much degrees is left between our gun facing the target. And if the degrees is less than, for example, 5 degrees, we can assume that we're facing the target and we can fire it. So what we're gonna do, we're gonna be using like a turret gun here and also our sync component. So get our transform here. And also the relative rotation of the gun. So what I want to do is to make a rotator here. And here I will make it for the pitch, for the current pitch and the target pitch. But target pitch is not here yet. So let's add the rotation target, store the variable of the target pitch. So it should be just this float clamp. That it's our target pitch. So we're gonna store here just to work here with it. So we're gonna be using target pitch here. All right, nice. So after that, we're gonna be using inverse transform rotation. Why? Because we need to understand its world rotation right now. So we're inverting from the local rotation to the world rotation. And after that, we're creating the new rotator. So for the both of them, we'll split them, and we'll use here pitch, and we also need a target yaw for that too. So yeah, not only the target pitch, but target yaw also. So let's get back to our function here, and after we're setting the world rotation here, we'll store like our target yaw, which will be kind of easy. It will be here. This is our target yaw. Yep, nice. So getting back here, we're going to be using the target yaw here. So this is going to be our first rotator, and our second rotator will be the turret body, world rotation. I'm gonna take the yaw of it and pitch here, so you can actually check. After that, we're going to be using the get rotation x vector for both of them, and here we'll do a bit of the math. We need to get a vector length, both of them also, and we'll find the dot product. After that, we will divide it by the vector length multiplied, and we'll find a cos degrees. And here we can actually check if it's less or equal. Our limit 5 degrees. So is it less than this limit? For example, let's put it like 5 degrees. And if it's okay, yeah, we can shoot. So yeah, something like that. Here we can also implement something like, the ammo count, that we can actually check if our turret have enough bullets to fire, or should it stop. But anyway, for now, let's just check. Could it fire? Ah, yes, sorry, it's the inputs to output. Well, actually, don't even use the branch here. Just return to the result. Right, so after that, in a tick, we can call this function and actually check if it can fire, and we can promote a variable where is can fire, for example, something like that. Boolean. Right, so if it can fire, we can now set up a timer also that will fire up every time from now on, which will be the fire rate of the turret. And if turret can fire, it can actually fire. All right, so let's create another timer. Will be a turret fire. And actually, let's create something like fire rate. And we will divide it. One by fire rate, so we can actually set the fire rate per second. So for example, it can make 20 rounds per second, and set it to loop. After that, we can create the function for the actual fire turret. So what we're gonna do here is first of all, we're gonna check can it fire. If it's not, we're not going to do anything. If it's okay, let's also check if our target is still valid. And if everything goes on, we can start to fire hit scan. So I will not create a bullet right now. I will just create a check that we can actually, like, get to the target, because sphere overlap actors doesn't understand, is it being obstructed by some obstacles? So it could be a wall, for example. So turret can actually, like, still keep target, but will not fire. If you want to, don't even keep it if it's not visible. So you can also utilize the hit scan function to actually check, does turret see it or not. Okay, for the fired hit scan, we will use something like turret gun. We use a get world location of it. Will be a very simple trace function. I'm gonna use the get forward vector. Can also implement a spread angle here, something like spread angle min, spread angle max, so to actually make the turret work, like, not just in every direction. So let's put them in like 2 degrees and 4 degrees for the max. We'll do like random floating range, and then random unit vector in cone in degrees. After that, we're gonna multiply it by our turret range, and add a world location, because that's is for the local, and now it will be a world location. And here we can use, for example, sphere trace by channel. You can also use a line trace by channel, but I suppose I will use this sphere to actually capture a bit more, something like that. All right, so now we can actually like break our hit results. And for the return node, what I want to do is to check if it was hit. So if it was hit, and if we hit our real target. So if we hit our real target, then it's okay. Also, I will return the location. I think I can return the false hit location too, because if we didn't hit anything, we need to return, like, the straightforward thing. So I think I'm gonna get the gun here, just multiply it by range, and add both of them. So it will be like false hit location. And also out hit, I will return here. We can use it for the applied damage. So this is our, like, fire hit scan. You can also like promote it to the, I forgot that I want to make it a separate function. So gonna be a fire hit scan. And in the fire turret, we're not gonna be using that much of the return nodes. So yeah, when the fire turret, we'll do a fire hit scan, and sorry, I need to, like, rename it here. Location false hit location. And if we hit something, it's okay. Right now we can, for example, spawn a bullet to hit, or maybe spawn some effects like that, and that's it. For now, I will do something like apply point damage. So actor that we will damage is our current target. The damage we can promote to variable and say this is our turret damage. For example, it will be something like 5. Our hit from direction to actually calculate it will be like get actor location minus the location from the fire hit scan, and we're using it to normalize. And here our hit from direction. Hit info, we have it here. And damage cursor is ourself. That's it. And for example, if in our component here on the destructible, we can create a event dispatcher, something like that, on death. So, and if it's dead, we can actually call on death. Oh, sorry, misclick. And in the turret target, on death, we can just do something like destroy actor. So we can actually see that our turret is destroying targets. For example, here, just to see that our turret really fires something, we can add, for example, a point light. I will not go through it like creating the effects here. So I will just here add a point light, make it something like orange. By default, its intensity gonna be 0, and a quick function like something like a flick light. Yeah, but this shouldn't be a function because I will be using the delay node, so it will be event. Flick fire flight. What I'm gonna do is just set the intensity of the light to maybe like 5000. After that, I'm gonna use the delay node. And after that, again, setting this to 0. So that's not a really good way to do it. Yeah, it's just to see that actually the fire is happening. So you can do it like that for the testing purposes, but don't do this like the final work. That's not good. Right. So after the fire turret, if everything okay, we just flick light. Right. Let's see what's going on. All right, it doesn't work for some reason. So let's check what's going on with the turret. First, let's find out, is it check if can fire working at all. I'll just use for now print string. And I will make that our guns rotating faster. For example, like maybe 80 here. So it's false. Yeah, it's true. So it actually sees the target and it's okay. All right. So, yeah. Again, I forgot to put the function here. So let's connect the fire turret here. Yeah, silly me. Always forget to do that, yeah. All right, let's check again. Yeah, so you actually see that the flight is flicking. It kills one target and gets to another one, kills it, and it's okay. So now we can even put more targets here for our turret to actually find them, attack them, check how it works. All right, attacks here. Now that target, that goes there. And it kills it also. So that's it, guys. Thank you for watching this tutorial, and this concludes the tutorial for the turret. What do you want to do now, and how you can extend it? As I said, you can add ammo to the turret. You can actually try to check is there any, like, walls or stuff like that, so the turret won't even face it. Because right now, if for example, like, put a wall here, it will still be able to, like, track the target, but at least it won't shoot it. And if you want to make it so it wouldn't even see that, you can actually use a fire hit scan to, like, to prevent it from targeting if they, like, if it's not in the field of view. So actually, as you can see, it's a bit rotated. So right now it's looking at their target, but it's not firing. You can see here. But if I will move here, it will attack. But this is the way of creating a turret without using any bone or bone sensing. Yeah, it could be a bit harder, but to me it's also a bit more interesting, and you don't have any limits to actually put a bone class for it. So thank you, guys. Thank you for watching. I hope you found this interesting, and see you next time.